Hi, today we're going to look at modeling something like this, sort of schematic representation of a strand of DNA that, even though it's sort of mechanical looking, blocky, low res, it's, I think, mostly anatomically or molecularly, structurally correct in terms of its proportions. So you see we have the major groove, the minor groove. We have the right number of base pairs per turn of the helix, and the relationship that the helices bear to each other is correct. So one is a duplicate of the other, but with a 130-degree rotation about the y-axis. So there are a number of ways we could do this. You know, you could model something like a ladder and twist it, but you tend to get a lot of deformations when you do that. What I prefer to do is to start with a helix that's modeled correctly to match the shape of DNA, and then we'll take an edge from one of these helices and use it as a motion path for this this elongated cube that we run up using a motion path on that curve, and then we create an animated snapshot, so it makes a duplicate of this curve this cube as it moves up the curve on every frame. Anyway, so let's try and do this. I'm just going to hide this, turn on my grid. So the first thing we want to do is go to create a helix. So in the polyhelix, we're going to give it 10 coils. So that means it's going to have 100 base pairs because I have 10 base pairs per turn, or thereabouts. Each turn is 3.4 angstroms, so we'll make this 34, right? The width, the diameter of the helix is 2, and then we'll just reduce the rate, so it's 20 angstroms. So we don't want 20. Wait, am I getting confused? No, we want 2, right? Yes, of course. So then we'll just reduce the radius to something else. So that looks about right. So now what we want to do, and we'll leave the history on here for now, because we might want to come back and change it. We want to grab the long edge that runs on the innermost surface here. So I think there is an obvious one to take here. If I can just get a good view. Looks like this one, maybe. Maybe it's this next one up here. Yeah, that looks better. Okay, so a great little tool in Maya is whenever you want to turn one type of thing into another, it's all under the Modify, Convert menu. And there's this great tool, just polygon edges to curve. So if you're modeling cleanly with quads and good edge loops, you can always extract a sometimes very useful curve from a polygon model in this way. So now I'm going to just make a little cube, and I want to scale this such that just going to be a little stick here, and I want it so that it's going to sort of reach out to the middle here. So what is that? 0.5 in x, 0.6, something like that. That looks about right. We can change it after. But the one thing we want to make sure of is that the pivot point is at its base. So I'm just going to hit Control 1 with this thing selected, so that hides everything else in the scene. And I'll just hit D on the keyboard to align it. Nope, I don't want to align it with that. I just want to pull it over and put it right on the edge here. And then, so hit D to get out of that, then hold down X to snap it to the middle of the world here. And then I'll just freeze its transformations and delete its history. I've got shortcuts for these too, so I'll use those in the future. Okay, so alright, so here's the trick. It's not really much of a trick, but we take this thing, let's call it BP demo, so base pair. It's one of these things. So we are going to select this, shift select the curve, and go to on your animation menu set to constrain motion paths, attach to motion path. You can open up the options. And so we want it to travel for actually 100 seconds. And the reason for that is because on every frame, I can have it duplicate. This is later on, but every frame I can have it duplicate itself in a new position. And I want 100 of them, so it will do, sorry, not 100 in sec, 100. This is 100 frames, not 100 seconds. And so then I want to figure out which axis I want to be the front axis. So here it would be, I think, negative X. Yeah, I think. And then the up axis, I guess, is Y. We can always change this later. And then we can attach this. And so we should see, is this what I want? Nope. Not exactly. So I want it pointing out from the curve, essentially. So right now it looks like it's using the negative Z as its axis. Wait. Yeah, blue is Z, right. Okay, so if we just go into the attribute editor to the motion path, front axis is a Z that we want and not the negative. Yeah, I think that's right. So, oh, that's at the end here. So it starts up here. Yeah, that looks right. And so it's just going down the path, just zooming down. So the next thing we want to check is that the animation is consistent, so it doesn't speed up and slow down at all. So we can check that by selecting the motion path and going to Windows, Animation Editors, Graph Editor. And so here is the motion path keyframes. So it has two keyframes. Its start value in U. So a curve has a U value. That's its the direction that it has along the curve. So the beginning of the curve has a U value of 0, and the end of the curve has a U value of 1. And I told it to get from the beginning to the end in 100 frames. But if we look at the interpolation that's described by this curve, this is saying that it slowly accelerates, and then it reaches its maximum velocity, it keeps it for a while, and then it slowly decelerates here. So this is called a flat curve or a tangent curve, which is nice because it gives nice ease out and ease in, so natural motion, but I don't want that. So I'm just going to select both of these keyframes, and up here use one of my interpolation presets. So this is linear, so there's no acceleration or deceleration. It just moves at a constant rate. So probably won't be really that noticeable because I'm just scrubbing here, but that will work. I'm going to save my file. So now if we go to, still under the animation menu, visualize, create animation snapshot. And these aren't the defaults. Defaults will look like this. Start time, end time is 1 and 10. We're going to change this to 1 and 100. So this means it will go from frame 1 to 100, and the increment is on every frame. So if this was 2, it would be every other frame. If it was 5, it would be every 5th frame, and so on. And it will make a duplicate of the model. So let's just do this. Click on this. I have to select the geometry. So I select the little cube, do snapshot, thinks for a few minutes, well, a second, and then there you go. It looks nice, eh? So these should all be reaching to the middle of the helix, because we're going to duplicate this group and then group it with the helix, the sugar backbone here, and rotate it. So we're almost there. I'm just going to duplicate. So the snapshot, it creates a new group with all our snapshots in it. So there should be 100 of these, right? Of these duplicates of our little guy there. So I'm going to hide the original. And this snapshot group I'm actually going to duplicate just so I have a backup that still has the history on in case I need it. And so now I'm going to delete the history on this new group that I made. And I'm going to group it with this helix. Okay? So I've got these two selected, and I'm going to hit Control G on the PC, Command G on the Mac. It's giving me a warning. I'm just going to save things. So now, let's see if I can rotate this. Okay. It's giving me a warning that there's going to be a double transform because the helix is still I'm going to hide the other snapshot group, and maybe that would solve it. But this helix is still got construction history to this polycurve, which has construction history to this original snapshot group. So if I rotate it, you can see how slow it was causing problems. So now if I hide those things and rotate the group, they all move together. Okay, so that's good. So now I'm just going to duplicate this special. Just don't copy and paste in Maya. Copying and pasting in Maya is not a good idea. You want to duplicate. So we can go to Edit. This is with the entire group selected that has both the snapshots and the helix. So we can go to Edit, Duplicate Special. Let me just reset this. And so we want to make a copy of this group. We can group under Parent, that's fine. And we want to rotate this. So these columns mean X, Y, and Z. So we want to rotate it with the Y-axis 130 degrees, just because that's the way DNA is. Number of copies, 1. That's it. So now we duplicate special. And they should all match up in the middle. And they meet at this kind of kink, which is fine. Now we can group these two groups together. Hope it doesn't crash. Nope. And there you go. You got your DNA. So you could rig this, do whatever you wanted. The other one, I just put a quick wave deformer on it. But you could go to deform nonlinear, and if I just put a sine wave, let's say, and just give it a small amplitude and give it a higher wavelength, so that amplitude is stretched out over a longer length, so the frequency is lower. And so offset, you can animate. Oh, it doesn't like that. There's a lot going on that doesn't seem to like. I've got my on-screen quality turned up a little bit, but I can just put a little expression under offset. So if I just Command or Control right click, go to expressions. So that was on offset. So I can just write a little expression saying offset equals time, semicolon, create. So just as an alternative to keyframing. Let's see if this will work. Okay, so there you go, a little strand of swaying DNA. And if we want to make this look all, future-y, we can select this group. It's a little slow to react. And let's assign a new material. Let's say something like a wireframe in Arnold. I think I have a light in the scene here. I do. And so if I just do a render here, It is off screen and it looks terrible. Oops. What am I doing? Yep. Right, so this looks a bit crummy. So I'm just going to select this and go to wireframe, turn this into polygons instead of triangles. That looks a little better. Maybe the line width can be a bit thicker. Fancy. So, and for when you, this is totally off topic, but when you do this kind of line work, you might, oh, I already have done it, but in the Arnold Renderer tab under filter down here, the default is Gaussian, and it's hard to notice, but it makes a slightly softer render. It's more aggressive blur, I guess. I don't really know the difference. I think it does 8 samples around each pixel or something. You can change this to something like box, which actually is a tiny bit sharper. So if this is the kind of look you're going for, you can do that. Probably won't make a huge difference. But there you go. A pretty straightforward way to make accurate, if sort of mechanical looking DNA. Thanks.